Okay, so just to repeat for purposes of the recording. So the fundamental theorem of algebra tells us as long as my n value, my degree is greater than or equal to 1, that's going to tell us how many answers we're going to have. And again, it's going to be some combination of rational, irrational, or complex. Could be all rational, could be all complex. It's most likely going to be some combination of the two. All right, so the first step in the problem, you could ignore this. The first step in the problem is to make sure that your problem is in standard form. What are we ignoring? This little note. All right, so is this problem in standard form? Yes. So since it's already in standard form, we don't have to do anything. Okay, once you put it, now if it's not in standard form, obviously you have to put it in standard form. Once it's in standard form, step number 2 is to find the possible rational roots. So now this relates back to what we did yesterday. So if you don't know how to find the possible rational roots, you're not going to be able to continue working on this problem. So what you'll need to do is stop, go back and look at that section, look in the textbook, borrow somebody's notes, go to Blackboard, whatever, and look up how to find the possible rational roots. What do we notice about the leading coefficient here? It's 1. So somebody else. Gerard, what is the fact that the leading coefficient is 1 tell us about the possible rational roots? They're going to be the same as what? We talked about it when we went over the bell work. What does the fact that the leading coefficient is 1 have to do with the possible rational roots? Lucas, what? Positive. No, not that they're all positive. Our possible rational roots are always going to be positives and negatives. How do we find the possible rational roots? What's our little fraction? The factors of the constant over the factors of the leading coefficient. And since the leading coefficient is 1, what does that tell us about the... They're the same. Good. So what are the possible rational roots? What are the factors of the constant here? 1, 2, and 4. So my possible rational roots are plus or minus 1, plus or minus 2, and plus or minus 4. Okay, so everybody understands? This is what we did yesterday, folks. So again, if this is puzzling to you, go back and look at your notes from yesterday. Look in the textbook. Talk to a friend. Google it. Look at Blackboard. Lots of different options for you to get how to do this.
So what did you do?
What? Yes. The factors of the constant over the factors of the leading coefficient. That's right. Okay. Okay, the next step is you're going to... Now, yesterday, we were looking just for rational roots. We're looking for all of the rational roots. So we plugged in all of the possible rational roots. Today, we're not going to do that. Today, we're only going to plug in until we get a hit. In other words, we're only going to plug in until we get a rational root. So here I've written the equation. And this is what I get when I plug 1 in. That's what P of 1 means. Remember, this is a function. The function is like a machine. We put values into the machine, stir it around, and our function gives us a different value. So here I'm plugging 1 into my function. This is my function. And then this is what I get. So let's figure out what my total is. So what is 1 to the 5th power? 1 to the 5th power is 1. Bring down my sign. What is 1 to the 4th power? 1. Bring down my sign. What is 1 to the 3rd power? And 1 times 3 is? 3. Bring down my sign. 1 to the 2nd power? 1 times 3? 3. 4 times 1? 4, and then plus 4. So what do I get when I add up those 6 numbers? Get a phone call.
Zero.
I get 0. So what that tells me is that 1 is one of my roots.
Yep.
So now I know I'm only going to be looking for 4 more.
Ooh.
Now, if 1 wasn't a root, then we would go on to -1, and then to 2, and then to negative. We would keep going until we got a value that works. Okay. All right, the next step, once we get a rational root, is we're going to then use synthetic division with this value in the box. That's what this means. Use synthetic division to divide the polynomial. This is my number that goes in the box. So my synthetic division is going to look like this. So if you're still fuzzy on synthetic division, you got to go back and look at it, because if you can't do synthetic division, you're not going to be able to solve this problem. Okay, so let's quickly run through this. So we bring down the 1, and we do 1 times 1, which is
1.
1. So now we get -1 plus 1, 0. 0 times 1, -3 plus 0, times 1, plus 3,
0.
times 1, plus -4, times 1, plus 4, 0. Okay, so you can ignore this part. What?
Double 4s.
What do you mean double 4?
That's supposed to be like 5. That means
What's supposed to be 5?
it's start 4.
Oh, yeah. I thought you were talking about something in the problem.
That's right. That's right.
I thought x4 was the x5.
Why?
Yeah.
Why do you think that?
Isn't it the first one?
Is that what we did with synthetic division? Look at your notes. We talked about this specifically.
Was that it? 3x to the second one?
Yes. All right, I'm choosing not to go back over the synthetic division. If you have any questions about how I got the trinomial, you have to go back and look at your notes. You have to go back and look at the textbook. You have to go back, because we did this already. This is from last week. You need to know how to do that. Okay. So once we do the synthetic division, the next step is to factor this. Okay, so we call that step 6. Step 6 is to factor the polynomial that you get. Now, if you notice, our leading term is x to the 4th. So we only have one method of factoring a trinomial when the leading term is x to the 4th. Does anybody know what that is?
The brackets of C.
No, can't do that. Okay, this is also something that we've already covered. We have to do the A substitution. That's where we're going to let A equal x squared. Again, we did this already. It's already in your notes. So I can say that x to the 4th can be written as x squared times x squared. Since I'm substituting A for x squared, I can make this A times A, which means I can make x to the 4th A squared. So this becomes A squared. Here I have an x squared, so that just becomes A, and then I have a 4. Now I have a quadratic expression where, Nikki, I can use the factors of C that add up to B. So now I can factor this. And since we're running out of time, I'm going to save us a little time. It's A minus 4 and A plus 1. Remember, I fooled the problem into thinking it's a quadratic. So now that I'm done and I've factored it, I can go back and put my x squared back in. So instead of my A, I'm going to get x squared minus 4 and x squared plus 1. Okay, just keep in mind that one of your answers is 1. Yes, sir?
Quick question. Yeah, this part confused me. Why? Just explain how we got the negative 4 plus 1.
The factors of negative 4 that add up to negative 3.
Thank you.
Negative 4 times positive 1 is negative 4. Negative 4 plus 1 is negative 3.
Okay.
Got it?
Yeah, I got it.
Okay, now, this is also, we've done this already, this is chapter 4. This is the difference of two perfect squares. You can factor that as x plus 2 and x minus 2. And then this is x squared plus 1. If those are my factors, my zeros are simply the opposite. So here, the value that makes this parenthesis equal 0 is negative 2. The value that makes this parenthesis 0 is positive 2. You may recall that when I have a situation like this, all I need to do is solve for x. So I set my equation up to be equal to 0. I solve for x by subtracting 1. I get that x squared is equal to negative 1. You will recall that when I have a square, the way I find the answer is to take the square root of both sides. So this becomes x. This becomes plus or minus the square root of negative 1. The square root of negative 1 is I. So what are my 5 answers? Remember from before, we had that x was equal to 1. We also have that x is equal to 2. X is equal to negative 2. X is equal to positive I. And x is equal to negative I. Those are my 5 answers.
That's great.
So again, you can see there were 3 or 4 different concepts that we've done in the past that you need to know in order to do this problem. So if you don't know them, you need to bone up. You can't just say, okay, that test is over, where's the new material? Because unlike other subjects which are linear, where there's not a lot, you read Romeo and Juliet, and then you read Catcher in the Rye. There's not a lot of similarities between the two books. But in math class, what we did yesterday is going to come into play on what we do today and what we do tomorrow. Okay, are there any questions? Yes, sir.
Where did you get the I and the negative I?
got that x is equal to plus or minus the square root of -1. The square root of -1 is I.
What about the negative I?
When you take the square root, remember you always get two answers, a plus and a minus. Remember, the square root of 25 is plus 5 and minus 5.
C.
Because minus 5 times minus 5 is 25. Sit down, folks, please. Wait for the bell. Ladies and gentlemen, sit down, please. Are there any other questions? Yes, ma'am.